Many may remember from their school geography course that Saturn's rings are a system of flat concentric formations made of ice and dust located in the planet's equatorial plane. Galileo Galilei was the first to observe Saturn's rings. He saw them through his ancient telescope with a 20-fold magnification in 1610. However, he did not identify the objects as rings. He thought he was seeing Saturn as triple with two appendages of unknown nature on either side, which he cryptically noted as longis anagramma. This anagram was deciphered as Altissimum planetam tergeminus observasi. I have observed the most distant planet as triple, and was published in a letter from Galileo to Julian de Medici on November 13, 1610. In 1612, the rings were edge-on and thus became invisible when observed through a telescope, which puzzled Galileo. They reappeared around half a century later. Christian Huygens became the first person to propose that Saturn was surrounded by a ring. He constructed a refracting telescope with a 50-fold magnification, much larger than Galileo's, through which he observed the planet. He published the results of his observations on March 5, 1656, decoding Galileo's anagram in his work Systema Saturnium in 1659. Returning to our planet, despite the moon's ability to wax and wane, appearing as a familiar globe shining in the night sky, what if one evening you looked up and saw a ring surrounding it, much like Saturn's rings? Scientists believe that Earth once had a ring, albeit billions of years ago. They hypothesize that the ring formed during the early stages of the Earth's moon formation. According to the widely accepted giant impact hypothesis, a planet called Theia collided with Earth in the distant past. This collision caused material to be ejected into Earth's orbit, forming a ring that eventually coalesced into the moon we see today. If this ring of debris existed within the Roche limit of Earth, there could still be a moon's ring. The Roche limit is a law named after the French mathematician Edouard Roche, who in 1848 determined that the planet's gravitational attraction on the moon is uneven. The planet exerts a greater gravitational force on the side of the moon facing it and a lesser force of gravity on the side facing away into space. This means that if the moon, a ring, or another object has an orbital trajectory too close to the planet, uneven gravitational attraction can tear it apart. Essentially, the Roche limit is the minimum distance at which an object can be from a planet and still hold itself together under the influence of its own gravity. If the original Earth's ring still existed, or new rings were formed as a result of another collision in Earth's orbit, it would be interesting. It all depends on your latitude and the direction of the ring's movement. Most likely, it would form parallel to Earth's equator and be visible in the sky with an east to west orientation near the equator. The rings would appear as thin bands of light that would flash from the far horizons of Earth and stretch into the sky. Depending on your distance from the equator, the appearance of the rings would change. They would become noticeably wider and larger. From some viewpoints, they would be so close to the horizon that they would seem within arm's reach. As for the gravitational effects, this mystery remains even for scientists. It all depends on the composition of our imaginary rings. As we mentioned in one of our previous videos, the disappearance of the moon would not be a catastrophe for humanity, although our neighbor does have a critical influence on Earth's tides. Similarly, the creation of rings would possibly pose tidal problems for areas closest to them. The rotation speed and tilt of the planet would likely change. There are no precise answers in this matter, and all we know for sure is that the transformation of our satellite into rings would not be fatal for all humanity. Just as the moon is not currently, hypothetically, these rings would reflect sunlight back to Earth at night, making them appear glowing in the night sky. They would likely reflect so much sunlight that our planet would never plunge into complete darkness and would remain in soft twilight even in deep night. During the day, the rings could also cause an increase in the level of light on Earth. Just try to think about what we are telling and showing you. Isn't it beautiful? Don't look at the round moon with its constantly changing landscapes, but at the rings. And while you're at it, don't forget to aim your cursor upward and give your cosmic like to support the channel. Write in the comments what other attires you would give to Earth if given the chance. We would be interested to hear your ideas. Now, let's continue. To see life from a different angle, remember the saying, niente è per sempre, which in Italian means nothing is forever. Even Saturn's rings disappear, and at a decent speed, calculations indicate that in about 100 million years or so, and pardon my Italian, gravity knows its business and attracts the material in a constant rain that falls onto the planet. The volume of this rain reaches approximately 11 tons per second. Consequently, the same thing would happen on Earth, albeit on a smaller scale. Areas where this rain would fall would be quite hazardous to health and sparsely inhabited. excluded. The residents of such interesting places would constantly have to be vigilant to avoid something falling on their heads. But now, back to reality. Earth actually already has rings. Scientists from NASA's Jet Propulsion Laboratory, using planetary radar at the Goldstone Observatory, discovered that at an altitude of 600 kilometers, there is a stream of small particles, 6.4 particles per square kilometer per day, ranging in size from 1.8 millimeters. 40% of these particles are concentrated in 1 or 2 orbits. One possible explanation is the presence of a ring system around our third planet, with an inclination of 35 and 1/10 degrees. Rings have also been found around all the gas giants of the solar system: Saturn, Jupiter, Uranus, Neptune, as well as around asteroids like Chariklo, Chiron, and Haumea, and hypothetically around Saturn's moon, Rhea. The possibility of short-lived rings in the past for other planets, including Earth, is not excluded. The fall of Phobos in a few tens of millions of years could lead to the formation of rings even around Mars. And that's all for now. Thank you for your attention. Please like this video, subscribe to the channel, and share with friends if you enjoyed this content. Until next time, stay with us.